Okay, so you've given us some info about AP Calculus AB, and we're going to try to really extract the core understanding of what this course is about, drawing from this description that we have.
Sounds good.
Let's jump right in.
Yeah, so looking at this, the most fundamental point is that AP Calculus AB is structured to be like the equivalent of a first semester of calculus at college.
Oh, wow.
So that already gives you a sense of the depth and the rigor that you can expect.
Yeah, that's a big signal right there, huh?
Yeah,
First semester college level stuff.
exactly.
All right, well, let's break it down a little bit. It looks like they break down the course into what they call core topics. So the first one listed is limits and continuity. So is that basically like how functions behave, smoothly or continuously?
Exactly. So limits help us analyze how a function behaves near a specific value. And continuity describes functions that don't have any sudden breaks or jumps. It's essential for everything else we build upon in calculus.
So like the foundation almost.
Yeah, it's really the foundation for everything else.
Interesting. And then we jump into derivatives and applications. So derivatives, I always think of them as like rates of change. Is that right? Like speed and acceleration.
Precisely. The derivative gives us the instantaneous rate of change.
Mm-hmm.
And its applications are vast. Like we use them in physics, economics, engineering, basically anything that involves change over time.
Oh, wow.
And it allows us to model those changes mathematically. Can you think of a real-world scenario where understanding the instantaneous rate of change is like way more valuable than just knowing the average rate?
Ooh. Let me think. Maybe something like tracking a stock price.
Yeah.
To know the exact moment when it, starts to surge.
Exactly. Or even like the speed of a rocket at launch, right? Like those precise moments.
Right. You need that precision. Okay.
Yeah.
All right. Definite and indefinite integrals. Oh, those always seemed a little bit like the opposite of derivatives, maybe. I don't know.
In a sense, yeah. Integration is all about accumulation. So definite integrals help us calculate the area under a curve, while indefinite integrals give us a family of functions that all have a specific derivative.
Okay. That makes sense. And then we've got the big one. Sounds very important. The fundamental theorem of calculus.
Oh, yeah. This is a cornerstone of calculus.
Yeah.
It basically establishes the relationship between differentiation and integration.
Yeah.
It shows that they're inverse processes.
Whoa.
Yeah. So instead of having to painstakingly sum up infinitely small areas, we can use the antiderivative to find the definite integral. It's incredibly powerful.
That's so cool how it all ties together. It's
Yeah.
not just these random things. It's all connected.
Exactly.
Okay. Next up, differential equations and slope fields.
All right. So differential equations involve a function and its derivatives. We use them to model situations where we know the rate of change, but not necessarily the function itself. And a slope field is a way to visually represent a differential equation. It's basically a bunch of tiny arrows on a graph. And each arrow shows the slope of the solution to the differential equation at that point. So you can kind of get a sense of how the solutions behave just by looking at the slope field.
Oh, interesting. So it's like a visual representation of change.
Exactly.
Exactly.
Very cool. And then finally, area and volume via integration. So that's using the accumulation idea, but for actual geometric shapes.
Yeah. Integration gives us the tools to calculate the area of all sorts of irregular shapes and the volumes of three-dimensional objects. So we've gone through what AP Calculus AB teaches, but now let's look at why it's structured this way by looking at the goals.
Yeah, good idea. Let's see what it says about goals. Okay, so it emphasizes understanding the meaning and application, not just formulas, and solving real-world problems. That makes a lot of sense. Exactly. The focus is on conceptual understanding. It wants you to be able to apply these tools to situations that you might encounter in the real world, not just memorize a bunch of formulas. And that aim to prepare for STEM majors really highlights its importance as a foundation for those fields. And then you see the prerequisites, right? Pre-calculus or algebra 2 with trigonometry.
Right. So you kind of need a good base in those before jumping into this.
Exactly. It sets the stage for what you need to know before diving into calculus.
So it sounds like AP Calculus AB provides a really strong foundation in the core concepts of calculus, which are limits, derivatives, integrals, but it really focuses on understanding and real-world application. It's not just about memorization.
Exactly. It's about building a conceptual framework that you can use to solve problems.
Okay. Well, that's a great overview of AP Calculus AB. Now that we've talked about all this, I'm kind of curious, what other fields, besides the obvious ones, might use these ideas of rates of change, accumulation, and modeling. It seems like those concepts could be useful in a lot of different areas.
That's a really interesting question.
Yeah, it's something to think about.
Definitely. I'm going to have to think about that one.
Yeah, me too.
Yeah.
Well, thanks for taking this deep dive with me. Until next time.
Thanks for having me.
Bye.